Hi, everyone. Hello, and welcome to today's webinar, How to Mitigate Intrinsic Safety. We'll be starting in just about 1 minute. We're going to allow just a small window of time for anyone who's running late to arrive. So we're looking forward to getting started here in just a moment. Okay, let's go ahead and kick things off. So hello and welcome. We're really excited to have you here for today's webinar, How to Mitigate Intrinsic Safety. When we do these webinars, we always like to acknowledge that we're living in difficult times. We started our webinar series back in early April, right when I think the economic impact of quarantine was really starting to hit a lot of folks, and that impact certainly hasn't gone away. So it's important to us just to acknowledge that people are struggling out there, people are suffering, and we just think that's an important thing to acknowledge. We also want to thank anyone who's doing essential work. So stay strong out there. We certainly know these are unusual times. That being said, we're really excited to have you guys here today. I'll be your moderator. My name is Zach Dukowitz. I'm the content marketing manager here at Flyability. And of course, today our presenter is Danny Landry, the Unmanned Operations Manager at Premium Inspections and Testing. A few housekeeping items before we dive in and I hand things over to Danny to do his presentation. So the first one is about engagement. We obviously can't have everyone's mics live. It would be chaotic. We have hundreds of people on, so we can't just have everyone allowed to, jump in and ask questions. So the next best option is to have you type your questions into the questions pane. So you'll see on your go-to dashboard that there's a Q&A pane. If you open that up, you can type a question in. Please don't feel like you need to wait to ask questions until the end of the session. We have several folks from the Flyability team who are fielding your questions. We'll try to answer some of them live in writing, but a lot of them will be saved and curated for the Q&A at the end. So if something pops into your head during Danny's presentation or really at any point, please feel free to type your question in and we'll be doing our best to answer every single question that we get. Another question that we get commonly is whether you'll have the chance to see a recording of this webinar. The answer is absolutely. So once the webinar is over, in the next 24 hours after that, we'll process the recording and we'll be sending it out to you so that you can peruse it sort of at your leisure. And the last thing to cover before I introduce Danny and hand things over to him is the agenda for today, so you can know what to expect. So we'll be doing this intro. It takes about 5 minutes. Danny will be presenting for about 30 minutes, 25 to 30 minutes on how to mitigate intrinsic safety. And then we'll have a panel discussion for about 25 to 30 minutes. That discussion will largely rely on questions that you ask. So again, please don't be shy. Please hop in, ask questions. We certainly want to make sure that if you came here to learn something, that you get that knowledge that you came here for. So all that being said, I'm really excited to introduce Danny Landry. So Danny, I said he's the Unmanned Operations Manager at Premium Inspection and Testing. He's also the VP of Business Development and Marketing for Premium Inspection and Testing as well. Danny's the former owner of Landbros Aerial, a leader in the drone service industry in the Gulf Coast. Landbros was one of the first drone service providers to get an FAA Section 333 exemption in the state of Louisiana. If you remember what those are, they allowed companies to operate drones commercially before the Part 107 rules existed. So really cutting edge work at its time. Throughout Danny's career, he and his team have serviced the majority of refinery and petrochemical facilities around the entire US. And through that work, they've gained valuable learning and feedback from those customers. Lambros Aerial was an early adopter of the Helios 1. That's how we got to know Danny. The Helios 1, as you probably know, was Flyability's drone made for flights in confined indoor spaces. Since then, we've released Generation 2, the Helios 2. Danny tested the Helios 1 when it first came out way back in 2016. Since then, he's had extensive experience flying the Helios 1 and the Helios 2 in inspection scenarios. Currently, Premium Inspection and Testing operates 5 different Helios 1 and Helios 2 drones in total. So Danny's got a lot of experience using drones in inspections and considering the question of mitigating intrinsic safety and whether drones are intrinsically safe, or how to use drones in inspection scenarios. So all of this being said, I'm going to hand things off to Danny now. Really excited to hear from him. So give me just one moment, Danny, and I will make you presenter.
No problem. Thank you all for having me today. I'm excited for this topic. There we go.
There we go.
Zach, can you confirm that you can see my screen here just to make sure?
Yes, sir. You are good to go. We can see your slides and you're all set.
Awesome. Everybody, thank you all for joining today. I know this has been a topic that has come up ever since the beginning of using the Helios 1. Flyability has given me a chance to talk about it because I know that as a whole, the first question everybody gets asked is, how much is it going to cost when it comes to these confined space inspections? And then the second question is always, is it intrinsically safe? And the short answer to that is no, but today we're going to dive into it. I'm going to show you all some of the options that may have been pitched out there that don't fit the description of intrinsically safe, but may be attractive to people that aren't aware. And then also I'm going to talk about how to mitigate and some of the options that are out there. So glad for y'all to join me. I'm going to go ahead and get started here. So here's our challenge, just to kind of give a quick overview of it. What we're trying to do here is we're trying to connect an inspection and a hazardous atmosphere, right? This is a vessel. This is a lower flare stack. This can be a sewage line. This can be a water line. All these different applications that we all know that Helios is so good at doing. In this case, we have a hazardous atmosphere. So we have hydrocarbons. We have, for some reason, that we can't get in there with a spark producing piece of equipment. So we want to do this inspection of this vessel so we don't have to put a person in there. And we want to do it without creating additional risk. So we don't want to take the risk of just putting something in there and not validating the risk mitigation. And we want to collect quality data, right? That's the whole reason that we're going in there. And then overall, we want to reduce human entry by, let's just say 40% for this inspection. And let's get that's our costs getting down by 40%. So essentially we have to do all these things, but then we're trying to get a cost efficiency as well. The solution would be use an intrinsically safe drone. But inherently there is an issue because based off all the research that we have read out there, based off my conversations with some of the aviation leads of the oil and gas super majors that are out there, there is no such thing as an intrinsically safe drone. And certainly if you have one and you have the certification, please let us know after this conversation. To show here, and I'm going to play a video here in a second, just a quick video to show you. This is an M210. It's a DJI product. It's very common in the industrial space. And just wanted to show y'all, this is a video that DJI did. And what they did was they started this aircraft in a propane environment. So they pumped propane into here and they started the aircraft. And what they found was that it did not spark the propane. Does that mean that instantly validates this equipment to be able to fly in a hydrocarbon atmosphere? Absolutely not. But it is worthwhile to look at and to watch. I'm going to play the quick video real quick, so just monitor your volume on your computer for me if you don't mind.
Ran it for a long period of time, very hard. They didn't light anything off. and to basically prove that atmosphere was flammable in there besides the metering that we did.
So you can see there that the aircraft was in the hazardous atmosphere and did not cause an explosion. The next video, if I can get it to load here.
It looked pretty awesome.
So this video here is whenever a spark was actually put into the air chamber and it was ignited. So you can kind of see here, give you an idea. Let's see, let me get back to my screen. Okay. So what that gives you an idea of what the consequences are if there are a spark, right? We have an explosion and we're in a bad situation. So we talk about intrinsically safe drones. Over the years, there have been many options that have been pitched to us. I'm sure many of the people that are on this webinar have seen some of these options before. I wanted to cover some of these false promises. I think that as a whole in the drone industry, everybody that's probably on this webinar has seen some sort of false promise within the drone industry, whether it's equipment or services or whatever it may be. So throughout the past decade, here are some of the examples that, for example, have been sent to me by refineries that say, hey, why don't you buy this aircraft? This one says that it's intrinsically safe. So I'm going to kind of review a few of those solutions here. And I think this is just a good thing to kind of get everybody's brain jogging and at least in the sense of everybody looking through these options and understanding that these are not real options to do intrinsically safe inspections. So this one here, if you're familiar with the DJI Mavic Pro platform, this is essentially a photoshopped mock-up of a Mavic Pro. If you really look into the image and you look into the reflection of the propellers, this was brought to us a few years back. We looked into it and a customer had sent it to us. Very expensive, and of course the seller couldn't provide any level of actual certification from any certification entity. So we were able to determine that this was not a real thing, or this was not something that we were interested in. This was another one that people were really excited about. This is 2017, so a little bit back in the drone industry. It was announced, and then it was supposed to come out in Q3 of 2018. It was actually announced, and it's still on their website, by the Intrinsically Safe store. And they actually do sell intrinsically safe cell phone covers to many of the oil and gas super majors. You may be familiar with them, but in this case, they launched this drone or said that they have this drone, and in reality, no one's ever put their hands on one before. It had an MSRP of only $3,500, and based off some of the research that I read out there, the responses they got were that, oh, it's still under development. It's still under development. Another one here, the Zayman Technologies LE4. These are just some of the claims. I mean, if you know anything about intrinsic safety and the sealing requirements and all the safety requirements that you would have to truly be intrinsically safe, you can just tell from this image that it would not be compliant. You can see an MSRP of about $120,000, so very expensive. And when you look at the image, you can see it's just a GoPro in a waterproof case. The wood propellers, the motors are still open, they're not sealed, there's exposed wires. And the seller here was not able to provide any level of certification either. So they did say that they had a Zone 2 ATEX certification, which the research proves that it was not able to, they're not able to validate that. Finally, one of the fourth ones, and I know there are other ones that are out there, but this one is the San George Technologies ATEX drone. This was one that is still on their website. It's pretty easy to find when you search intrinsically safe drone. This one's actually very interesting because the concept is that it uses pneumatically powered motors here, which you can see. are powered through the compressed air that's pumped through that tether that you see, the blue tether, and it's able to propel the aircraft and keep it airborne. Again, this is one that it's just a concept, and you know, in the research they talked to this manufacturer, and it was more of a project in development, and there was no price listed, no availability listed, and you know, again, this was launched in like 2017, so I wouldn't get your hopes up too high. So the conclusion of this, at least in my opinion, and I would think many people would agree with me, is that currently there are no certified intrinsically safe drones that exist. So people still need to provide those inspections inside of those hazardous atmospheres without having to put personnel in there. So what are our options? What can we do to mitigate that? So when that question comes up from the facility or for the customer, and they say, oh, it's intrinsically safe, the answer should be, the aircraft is not intrinsically safe, but we may be able to mitigate the atmosphere in which it operates in. I did want to touch on some of the solutions that are out there that are truly intrinsically safe. We see these with our company. We use these on a regular basis. There's one camera that's known. There's some other ones that are out there, but at least in the RVI or remote visual inspection space, there's a Pairpoint camera, and there's also some of the sewer crawlers that are explosion proof. The Pairpoint camera is certified C1D1, which is very important. And then the other ones are just available in explosion proof models. So that certification isn't necessarily there, but they do have the nitrogen purges that make them explosion proof. There are many other in-service tank inspection options available as well. Just keep that in mind. I'm not going to go through all of those, but that is something that is out there. So let's move on to the mitigation side of it. So I'm trying to just keep this as simple as possible. You know, what you have to do is get the environment to a non-explosive status or to a safe status. Step one, and these are just some rough steps to follow, is work with your safety or industrial hygiene department. So if it's your facility, you want to work with them. If you're a contractor or a service provider, then you want to contact that facility and say, hey, we need to talk to this department. And I would recommend doing this, you know, a few weeks in advance, or even a few months in advance if you have that far of lead time. And you need to ask some of the questions, you know, is a management of change or MOC needed, right? A lot of facilities have specific rules that say non-intrinsically safe tools cannot go into these vessels, or battery powered tools cannot go into these vessels. So it's very important to make sure that there is some sort of procedure or documentation that covers this change from the normal, right? Because these drones weren't available 10 years ago. Also, you need to have the conversation of, is this mitigation even possible, right? You cannot be afraid to walk away from these projects. The Helios 2 is an amazing aircraft, and we use it all the time, and we're very satisfied with it. But there are many times that we've just had to say, hey, it's not possible to do this safely, so we're not interested in doing it. And customers, 9 times out of 10, always understand that. Step two, if you decide that it is possible to mitigate that environment, you need to clean and clear the vessel of the hydrocarbons. Depending on the vessel, so if you have a vessel that you cannot clean fast enough, or you're not able to get all the hydrocarbons out, you may put it under a nitrogen purge. So in that case, the aircraft, just so you know, does fly very well in a nitrogen purge, and that helps mitigate that spark risk. Step three, say the vessel is under the nitrogen purge and you're going in to fly into it. I recommend gas testing at multiple points to ensure that the lower explosive limit is an acceptable level. So in that MOC, the LEL level can vary, right? Some sites are different than others, and everybody has different requirements. So you just want to make sure that's acceptable in monitoring the entire time from multiple points. So finding different testing tubes, different areas to put those meters and get a constant monitoring. Also a part of that is proper permitting. I think that in my experience, we always recommend that no matter what, if we're in a facility that has a safe work permit system, we always get a permit. It's good for documentation, but in this case, you absolutely want to get a permit. Most likely, it's going to be a hot work permit. In some cases, they will treat it as an entry, even though a human actually isn't going to be entering in or breaking that threshold. So just keep that in mind, that really put a lot of attention on that. Make sure the safety department's involved and go above and beyond. Step 4, once the the vessel or wherever you're flying in is mitigated, you can energize the aircraft, complete the inspection, and complete the mission. Step 5, very, very important. After the mission, be sure to debrief, review learnings and areas of improvement. And also, I think it's very important to calculate your return on investment. How much were you able to save, right? What was the reduction in cleaning costs? What was the reduction in breathing air costs that are associated with this inspection? Normally, if you had to put humans in there and they're under breathing air, you'd have the bottle rentals and the equipment rentals, not to mention just the general safety risk of putting a person inside. And then additional best practices, just a few notes that I wanted to put on here for y'all. Asking for a waiver from the customer for damage to the aircraft in case there were to be something that happened and the aircraft was lost in the vessel. Many times customers will not allow this to happen. They won't sign off on the waiver, but it's worth it to ask the questions, right? So ask the question of, if we were to leave the aircraft in the vessel, what would the consequences be? If we were to lose control of the aircraft in the vessel, would we be able to get it out? So very important questions that we ask every time we operate. And I recommend that you look at yourself and do the same. Try to avoid charging of batteries on sites where there are hydrocarbons. In general, I think this goes to say that you should just buy enough batteries so you don't have to do any charging on site. Charging batteries is one of your higher risk activities, and I recommend that you don't do it while it's on site. Next item, prepare for the worst. Do not take chances. I think this just goes with every operation is be prepared. If you were to have an incident, how would you respond? Have your emergency response plan built out. This is going to be a higher risk operation than most because obviously you have a hydrocarbon atmosphere. And then operate conservatively. So don't rush things, don't force things. Take your time. Make sure that your vessel is mitigated, and don't be afraid to use your stop work authority. I'm going to jump into a few videos here, and what I kind of want to show you is just an inspection that we did. This was actually with the Ilios 1, so excuse the cage. I'm going to play a quick video. Just be aware that the sound is going to be very loud from the Ilios 1, so just be aware of that.
Hey, Danny.
Yes.
Hey, I think we had some folks who were having trouble seeing the video previously. I think it might be solved by, in the drop-down menu, if you select only the video, although that might be how you're already doing it, so it could just be an issue that has to do with the version of GoToWebinar people are using. Anyway, go ahead and play the video. I'm going to back out now.
Yeah, I'm just clicking the one video. So.
Okay.
For the purpose of that video, if I can get it to close here. Was to show you how we mitigated the risk here. So we cleaned the vessel the best we could. Then we blocked off the manway. You can see the visqueen here. And then as we go, you can see the 2 tubes of nitrogen that are going into the vessel and keeping constant pressure of nitrogen into the vessel. If you listen to that, I know it was difficult to hear because of all of the noise, but you could actually hear the nitrogen hissing into the vessel to keep that purge active. And then we had multiple points of testing on that vessel. I'm going to go to the actual inspection just to show you that quickly. Again, just showing some of the data that we're able to capture. If anybody on here has used the Helios 2, you know that for one thing, you don't have a microphone on the camera, so you're not capturing that loud bee noise. And number two, you don't have the cage in front of the camera, and you have options for a little bit higher resolution. So just wanted to show just kind of a quick snippet of the data and able to fly in that nitrogen purge in an atmosphere that normally would be combustible. And there's a still image for y'all. So to talk about the future, and it looks like we're staying on track in terms of time, will we ever get a certified intrinsically safe drone? On my end, I'm definitely not holding my breath. I would love if one would come out. It would make our business probably explode in a very positive way. But I'm not depending that it's going to happen. It's going to be very difficult with the restrictions on the intrinsic certification, the ATEX standards, the CE standards. They're very, very strict, and facilities do require those standards whenever you're working in those areas. And I put the question on here, how long will it take? Because I figure somebody's going to probably ask me that anyway. And how long it will take, I have no idea. I think everybody knows in the drone industry that question's always asked, right? Urban air delivery, beyond visual line of sight. When will we see it? Everybody said it was going to be 2 years, and that was 5 years ago, right? And it's still not here. So it's a difficult question, and there's not really an answer for it. So in our case, it's let's focus on right now. Let's see how we can mitigate the risk and how we can still provide solutions. And that goes along with this webinar is education, right? If we can educate everybody that, you know, in some case, this is a good application, right? We can mitigate the risk. We can find applications that work. I will add to it that most of the use cases are during a planned or unplanned shutdown in these facilities. So your everyday maintenance, it's just not going to happen as much, right? It's going to take a whole lot more. Those process vessels are in their process. So keep that in mind. That's pretty much all I have. I'm going to switch it over to Zach so we can go through the questions, and hopefully that was very informative for y'all. Zach, you should have control.
Hi, everyone. I'm just bouncing in real quick. Zach is having issues with unmuting. We're just trying to figure it out, which is why we've gone silent right now. If you'll just give us a sec, we'll figure it out. Sorry about that, everyone. We're still working on trying to figure out why we can't mute. Seems to be the woes of our time. Okay, well, while Zach is trying to get back in, we can get started on the webinar already, on the Q&A, I mean, and once Zach gets back in, we'll go over the past webinars, the upcoming webinars and everything else he needs to go through. In the meantime, Danny, maybe we can get started on the Q&A with a few questions while Zach gets back in. So we had a few questions during the, while you were speaking, and so I'll just take some audience questions as they came in. So the first one we had was from Andre, who was asking if drones can be safely operated inside of a nitrogen atmosphere. I believe you touched on that, but could you maybe expand a little bit? Oh, Danny, you are muted too.
There you go. There you go. Can you ask a question
Okay.
as well? I'm unmuted as well. I mean, I'm unmuted now.
Okay. Did you get the question?
Can you repeat it?
Yes. So the question from Andrew was, can drones be safely operated in a nitrogen atmosphere? I know you touched on that, but maybe you can expand a little bit.
Yes, they can be. We noticed that there was a little bit loss of lift in the times that we have flown in these purges. But other than that, there's no significant performance issues that we've been able to notice in the nitrogen purge.
Thank you. Is there anything else maybe that would be good to know for people listening in on how to operate within a nitrogen saturated environment?
I think that the main thing is that the environment is saturated with nitrogen and that there are no other hydrocarbons. But actually flying in the purge, I would say that the flight characteristics, and then I guess the other challenge too, is that if you have the manway blocked off, as you saw in that video, you're not able to see the drone from outside. So you're flying full FPV. And when you're flying full FPV, you obviously have that millisecond or two delay from the screen to the camera or vice versa. And whenever you have that, it's going to be a little bit more difficult to fly. Thankfully for the Helios 2, it's a little bit easier, right? But for the Helios 1, it's a little bit more difficult. So thankfully we have that upgrades with the positioning, but that is something to note as well.
Thank you. The next question we have comes from Paul, who is asking us where you plug your batteries in, into the Helios. He continues by saying there's always a small spark, which can be unacceptable in a petrochem facility. So how do you get around that little spark you get when you plug in your battery?
Yeah, so as well as the area in which we're mitigating inside of the vessel, we also have to be sure that the area in which we're standing in when we energize the aircraft, it is hydrocarbon free as well. So to mitigate that, all of our crew members wear 4-gas meters at all times, pre-job testing, pre-job walk down, testing that area. So if there's a concern that there are hydrocarbons in that area, we won't even be in that area, let alone going into the vessel. But it is a good point. There definitely would be a spark, or there definitely is a spark. But mitigation of that environment, you wouldn't want to be in that environment in any aspect.
Right, most definitely. Now we have a question from Patrick, who's saying, is there ever a point where you would say no to a project?
Absolutely. We say no pretty often. People have really great ideas, and that's what's kind of inspired us to do a lot of the unique things that we do. But people also have a lot of crazy ideas and ideas that aren't safe. And I guess that it's good that you have people coming to us with those ideas, and we love those ideas. But at least we know the technology, and we've learned enough over the years where we're comfortable saying no whenever the answer needs to be no.
I can totally reflect that. We enjoy these crazy requests sometimes because that's what pushes innovation, right? People trying to do something that hasn't been done before, and I know you've been doing a lot of that personally. Now let's see what else we have. I have a question from Kevin, who is saying that one of his customers for a refinery is asking if Helios can be used to check a storage tank, and they advise them that it's possible if they purge the tank before proceeding. Would you say that is correct?
That's correct. If depending on the type of tank, if it's a floating roof tank or a fixed roof tank or an internal floater tank, depends on what's in the tank and which hydrocarbon is in there. But we definitely do storage tanks on a regular basis, but they do have to have some sort of mitigation measure, whether they're fully cleaned out, whether they're drained and purged. But yes, it is possible.
Thank you. Now the next question comes from Michael, who is asking, how do you mitigate the risk in outdoor ATEX environment? Which I'm really curious to hear too.
Yeah, no, that's a good one. So if you have an area, right? So if you have a classification zone that may cover, say, let's just a 25-foot or a 50-foot bubble, you would treat that the same as if you were inside of the vessel, right? So if you had those hydrocarbons present, and obviously you can't put the purge on the exterior environment, you just wouldn't be able to fly.
Right.
Also, keep that in mind that with proper gas testing, I mean, if you go in some facilities, almost the entire facility may be under classification zones, and that's maybe why you have a management of change, or you have a safe standoff distance. Very commonly, it's, if we have a 50-foot safe standoff distance, then that's going to be something that's going to keep us outside of those electrical classification zones. But absolutely, that's a really good question. And we see that a lot. Every site is different. We have some sites we operate in that say that you cannot even fly over a classification area. So if you have a tank farm that has a classification area, then you can't even fly over it, even if you're at 400 feet. So if that's the case, then we abide by that. And if they want to change the rule, they can do an MOC. But it's something that definitely does come up at some sites.
So I have not actually ever considered that one. Very interesting. I see that Zach is back. I'm going to let him take over and go back to the back ends of the workings here. Thank you, Danny.
Hey everyone, and my apologies. In this new world of living through a pandemic, there's always some kind of issue with the webinar platform. So today's issue was audio related, but we're back. So Danny, I have a question for you about LEL, and I'm wondering if you can tell us what the permissible level of LEL would be acceptable for flight operations. If you can speak to the permissible level of LEL for flying drones.
Right. So it does vary. As a whole, you'd probably want to say 0 would be a confident level. There are situations where you may allow, maybe 1% or 2%, but for the most part, I would say that you would stick to 0 LAL. So I would just say it's a difficult question, but that one kind of yields to the facility and then analyzing the project as a whole and the risk as a whole.
Got it. Thank you. A related question that I think folks have when they're imagining the things that could go wrong when you send a drone into a confined space. What do you do if the drone gets stuck? How can you get it out? How would you get it out? What are the consequences of maybe having to leave it in? If you could speak to that.
Good question. So whenever we're analyzing the flight and we're doing a pre-job brief with the facility, we're going to ask them the question I mentioned earlier: if we were to lose the aircraft, would we be able to get it out? So would we be able to put a human in there to go get it if we needed to? And then if we had lodged it in there where we can't get it out, can we leave it in there, right? So if you have a chimney stack or something like that where you could leave the aircraft in there and it could burn up and it wouldn't be a risk to the vessel. So that's possible as well. But I would say as a whole, normally the customer says, yes, it needs to come out. You need to make sure that it doesn't get stuck in there, and we're not going to cover the damage. So what a lot of times we do is we use mitigation measures like tethers. So we'll actually tether the Ilios through just a hard tether, not a power or anything like that tether. That way we have a safety tether and we can pull it out if we were to get in a tough situation. Also, you can use like a extended hook or something like that, a hook on a pole, so you can get them out, get the Ilios out if it were to get stuck somewhere. So just as long as you have a backup plan in case it were to get lodged, that's something that would be important. So.
Great, thank you. I have another question. This one's from Gavin. He's asking, you'd mentioned occasionally maybe having to walk away from a job due to safety concerns, and he's just wondering how often have you ever done that, you know, if at all, or have you run into scenarios where a client insists on a mission that you feel just can't be done safely and walked away?
Good question. I see that in this day and age, stop work authority is becoming almost universal. So that authority to walk off of a job, and you're not really walking off, right? I mean, it's more of like you're just saying, I don't feel comfortable doing this. I would say almost every site respects that decision. It varies how often we see it. Normally, it's something where upfront we're communicating that if there is a hydrocarbon atmosphere, unless we can absolutely mitigate it, we just can't fly in it. And pre-communication is absolutely crucial for that. And then that way you don't even ever show up on site, right? You know that it's not feasible before you even get there. You may know it's not feasible before you even quote the project. So early communication, not committing to things that you don't know how to do, and making sure that you're a competent operator is very important in those situations.
Got it. Thank you very much. We have a question from Michael, who's asking about mitigating risk in outdoor ATEX environments, and he's just wondering how you mitigate risk in those scenarios.
Yeah, I think that is similar to the question that, I don't know if Michael asked it earlier, but Alex had asked it of me, is basically being aware that seeing what the procedure is of the site, and that obviously if you have a hydrocarbon atmosphere, you don't want to be flying in it, whether it's external or internal. So safe distance from assets, proper gas testing, all those things are important.
Got it. Thank you very much. We have a question from Yi Kwan, who's asking, has there been any scenario where an into tube was attached to the Helios to create a localized purge area around the UA?
We have never done that before. That's a good idea. But from what we've seen, even with gas testing from drones, is that the prop wash from the propellers seem to disturb the air pocket around the aircraft. So what you would have is, even if you had that N2 tube pumping nitrogen bubble around the aircraft, the propellers would be moving the nitrogen so much that you wouldn't be able to maintain that bubble. So I don't believe that it would safely work, no.
Got it. Interesting.
Good question, though. That's one of those good ideas for sure.
Yeah. And I think it's something, we're all troubleshooting, right? So here's a sort of an open-ended question. Can you tell us about some of the most challenging inspection scenarios that you've faced, specific to using drones or otherwise?
Yeah, I would say probably the most challenging inspection that we've done with the Helios 1 or the Helios 2 is when we've had to actually go into the top of stacks. So if you're flying up and into a stack, those can be very difficult because most of the time when you have a stack, it's high up and there's wind, and obviously the stack is completely shut down. This is on a turnaround. But that's been some of the more challenging jobs that we've done. Normally, it's always better to go from the base and fly up if you have some sort of furnace refractory inspection or something like that. Other than that, other challenges are going to be anywhere where there's a lot of draft, right? So if you've maybe got a cogen unit or something like that, and you have a draft flowing through the vessel, it's going to be more difficult. If you have a tank and you have a lot of fans that are venting the tank, it's going to cause draft again. So the Helios 2 has helped with a lot of those issues with the positioning, but definitely still present, and definitely still there. Even with the Helios 2's positioning, there's still some challenges, especially on the external stuff. But yeah, draft is probably your biggest thing. Lighting, the Helios does a really good job of the lighting and the camera settings, so that's really never an issue. But yeah, that'd probably be the biggest challenges that we've had, is flying up and into stacks.
Got it. Thanks, Danny. Another sort of open-ended question from the audience is, what are some of the most common issues reported in your inspections? What are the most common issues that you find in your final inspections?
So it depends on what we're inspecting. If, say, we're doing an Helios inspection of a furnace stack and it's refractory lined, we're looking at refractory damage. So cracking, spalling is going to be your main issue. Significant spalling that may be occurring whenever we're going in. Sometimes we go into tanks that, say a tank that's been damaged, and they're trying to investigate how the damage occurred. So it could be finding where the root cause was of the failure. The routine stuff is kind of normally, the stacks. I would say one of the cool projects that we've done has been going into a convection setter of a furnace and looking at the shock tubes, looking for leaking, doing the inspections while the vessels are under a hydro test, right? You couldn't put a person in there during the hydro test. So it's very nice to be able to put a piece of equipment in there, lowering the risk and be able to conduct the inspection while there's a hydro test going on. So in that case, looking for leaks, looking for corrosion, and the list goes on. Anything that you would visually inspect with an inspector, you would hopefully be doing with the Elias and finding with the Elias.
Right. Yeah, that makes sense. To get a little specific, can you tell us about a specific risk mitigation scenario in which you've used the Ilios 2 and maybe the benefits the Ilios 2 provided?
Are you saying in an intrinsic atmosphere or a hydrocarbon atmosphere, or just in general?
Whatever springs to mind, really. It's a question from the audience, but I think people are just interested in hearing about concrete use cases. So, I mean, given the title of the webinar, I guess intrinsic safety would be great. But if anything that springs to mind, I think that where you found the Ilios 2 useful, or the ability to use drones useful, I think.
No, I think that the Ilias 2 has been a game changer for us. We've done so many different internal inspections with it, and the customer response has been even greater than what we got with the Ilias 1, right? Pretty much all the complaints of the Ilias 1 have been resolved with the Ilias 2. Specifically, some of the challenges when people wanted to get 3D data of the inside of their vessels, you weren't able to do that with the Ilias 1 because of the cage in front of it, or you could, but it was really difficult. Now with the Ilias 2, we can go in and we can actually 3D model some of these vessels that we're looking at, some of these lines that we're looking at. So another one, cooling tower. We've done internal cooling tower inspections, so that was pretty cool. Had a four bay cooling tower, and essentially they would turn off one of the bays, turn off the fan of the bay. We would fly the aircraft inside of the cooling tower bay, do the inspection, and then fly out, and they would turn that fan back on, switch to the other fan, fly into there, do the visual inspection, fly out. That was a really great one because they didn't actually have to shut down the whole system, right? They could still provide the cooling support they needed to because they were only shutting down one of four at a time. Another pretty cool one, we've done some internal coat drum inspections that are always pretty nice, just because they're big and sexy in a sense, right? Because they're obviously money makers for the site. We've really got an endless list. I'm trying to rack my brain for some more examples here.
Well, those are plenty, and I know I put you on the spot, so don't feel bad if there's not other. I mean, that was a pretty good list that you just gave us, Danny. But if you have others, I certainly don't want to cut you off. But we, yeah, whatever's good.
Yeah, I mean, I think general tank inspections, those aren't as much, I guess, fun to talk about because you're doing a tank inspection. But I would say for one thing, API 570 inspection, we're actually able to supplement that inspection with the drone. So I know that's a big topic that people have is, hey, can I use this drone to satisfy this API inspection? And you can't just use the drone, but the drone can be a part of that inspection and help save you on scaffolding and help reduce your time on site. So I know personally, I went up to a site up in Illinois, and we did an internal tank inspection with one of our 570s, and him and I were able to work together, and we were able to capture the top of the tank and the rafters and the supports, and he was able to sign off on that 570. He did have to do all of his other standard 570 requirements, but he didn't have to build the rolling scaffolding inside of the vessel to access those points. So something like that, you're seeing between like a $7,000 and $15,000 cost savings, which, you know, when you're doing a lot of tanks, it adds up. If you're eliminating a full scaffolding build, you could be creating much greater cost savings. And I should have mentioned that in the other ones on the furnace stacks, we see around $17,000 to $70,000 cost savings on those refractory line furnace stacks. I know that's a wide range, but it depends on the complexity of the stack and how much of the supports that we're doing. Underneath coker inspections, looking at coke slides, the list goes on and on. Pretty much everything you can look at in the facility, we've probably you know, put the ELOS in if we've been able to and safely do it. So if you'll have any questions outside of it, I know my contact information is on there. Feel free to shoot me any applications or crazy ideas that you may have.
And you mentioned savings in the, you know, one boiler inspection or one tank inspection, I should say. And are there also savings related to reduced downtimes when you're using a drone instead of needing to build scaffolding and send a person in?
For sure. I mean, the reduced downtime cost savings, I mean, you can look online, the numbers are massive, right? I mean, that's when you get into the $500,000 to $1 million range. When we're doing our KPIs and we're tracking on site, what I'm giving you, like the $70,000 cost saving, that's a true cost savings of what you're spending versus what else you're spending. In addition to that, you have the downtime cost savings. In addition to that, you have the safety cost savings. So all those things play into it. It can be difficult to estimate the downtime, and that's kind of on a facility to facility basis.
Got it. Thank you very much. We've got we got a question from two different folks that I think are basically asking the same question, Matthew and Bert. Matthew's asking if the operator's gas meter alarm goes off, he'll need to immediately power down the drone. And Bert's asking, is there a way to shut the drone down with the remote to avoid risk or limit risk if some sort of scenario suddenly arises that would require powering the drone down? Have you ever had that happen, and can you power the drone down remotely if needed, given that kind of scenario?
It's a great question. So you can turn off the motors. You're not able to fully power it down. You can turn off the LEDs. You can put it into a safe landing mode. If we were in that scenario, we would certainly turn the motors off. We'd safe land it, turn the motors off, because if we were to just shut it down mid-flight, we could cause a spark if it were to crash land inside of the vessel. And then most of the time, if we're looking at a scenario like that, we're probably going to have a tether. And the tether enables us where we can pull it out very quickly, get it out of the vessel, and clear the area out. So, but short answer, no, you cannot remotely shut down. At least I'm not aware of that feature currently.
Got it. Thank you. Let's see. Oh, we have someone, so this is something we're hearing about a lot these days. There's a lot of buzz around 5G, and Frank's asking regarding testing. Have you tried to connect with 5G LTE Technic? Have you done any testing with 5G? Just curious.
We have not. Pretty much all of our customers want us to be off of the network. They do not want their data on the network. That's one of the beautiful things about Flyability, and you can read on their website their data control procedures. But you can truly control your data, and it doesn't go back to a server. And so whenever you connect to the LTE, whether it's 4G or 5G, you're going to have that risk. So at this point, no, we're not testing it, and we'll probably take directive from some of our oil and gas companies that we do work for, and let them kind of direct us on, hey, this is what we want to see, this is where we need to have data control in place, and then follow those steps so we can be conservative about it.
Got it. Thank you. We have a question from Cesar, who's asking, it's related to the possibility of losing the drone, and he's just asking, have you ever run into a scenario where the drone's battery runs out and you can't enter the space to recover the drone? Have you ever lost a drone, I guess, is really the question.
Yeah, so in terms of going into the space, we've never had a situation where we haven't been able to find a way to get it out, right? So whether it's using like a retrieval pole, or again using a tether is always a good tool to be able to pull the aircraft out. We have had instances where the battery has gone low and it's done the safe landing where it just comes down and lands flat on the ground, and then you have to get it out with either the tether or the pole. We really do put a lot of trust into our tethers. We at least fly our first mission with a tether so that we can, scout out the environment and make sure that we can potentially fly it without a tether. But that's kind of the safeguard we use that helps us to mitigate that risk.
Got it. Thank you. And we have a question. You've mentioned tethers a few different times today, Danny, and John in the audience is asking, he says, I've been advised using a tether isn't recommended on the Helios 2. Is that correct? What mitigations would need to be considered when using a tether? So yeah, anything you can say about using tethers with the Helios 2?
Yeah, good question. Helios 2 is much more difficult to use a tether with because of the way it's oriented. The Helios 1 was a little bit easier because your cage rotated around your aircraft, right? You have the gyro ability, whereas the Helios 2 is more fixed. So it's directional, right? So depending on where you're trying to go and what you're trying to do, that's how you'll have to affix that tether. But it can become a challenge. I know the Helios 1 was easier. And again, the Helios 1 is still a great aircraft, and we still do fly it. Most of the time, we're flying the Helios 2 these days. But if you were to have a high risk environment in terms of obstacles and things like that, we would most likely fly our first mission with an Helios 1 with a tether, ensure that we felt comfortable with the environment, and then we would probably fly the Helios 2 without a tether. And we almost always bring 2 drones with us on site if we're able to.
Awesome. That's really helpful. We have a question from Matthew, who's wondering, will the drone land itself in a controlled manner? Really, I guess just asking about the end of a mission and how easy it might be or difficult to bring the Helios back and to land it.
Yeah, so it has a safe landing feature when the battery gets low, but also depending on where you're flying into, depending how big your manway is. So if you have a 16.5-inch manway, it's a lot more difficult to thread that needle and get it out. Whereas if you have a 24-inch or greater manway, then you wouldn't have as much of a concern. So it just depends on the environment. But as a whole, I mean, you are manually flying it. Every pilot has a different way that they like to fly certain things. We have certain best practices that we use in terms of orientation and how to get out of that vessel. Being conservative about your battery to make sure that you're not rushing your landing is very critical. You want to plan enough time. You want to have enough batteries so that you don't have to take those chances when they come up.
Got it. Thanks so much. We have a question from Gavin in the audience, and I just want to acknowledge we're just a few minutes away from the hour, so we'll probably go just a few minutes over, but this will be the last question for today. The question from Gavin, though, Danny, is how often do you see customers asking for 3D data sets? And I guess if you could just speak generally to whether you use indoor photogrammetry, indoor 3D modeling often, or what that looks like for your deliverables.
Yeah, so on the with the Helios 2, we see it more of something right now where the customer isn't used to it. So we're adding it on and offering it. It's still very new, so people aren't a ton of people aren't coming forward right now and asking for it. I will say that some are. Ones that have seen the Helios 2 footage and we've done the inspection, we've created a 3D model for them to showcase it. They are coming back and saying, now we want the 3D model. So yes, we're using photogrammetry software. We use a few of the ones that are out there, and we're able to create these deliverables. But I would think that the demand would continuously increase as people see the data. Again, that's why these webinars are so great, is because we're educating and we're talking about it, and people are learning more and more about what's possible.
Awesome. Thanks so much, Danny. I'm actually going to ask one more question, but before I do that, I just want to cover a few things I would have covered if the audio issue hadn't sort of thrown a monkey wrench into things. So real quick, we just want to say that today's webinar is part of an ongoing series. the series first started with content from in-person user conference we had scheduled in March that was going to take place in Denver, where we opened our first US office this year. Of course, due to the pandemic, we couldn't do that, so we converted all of the keynotes into webinars. What you see up on the screen is a list of the webinars we've already held. All of these are available on demand on our website. And these webinars as well, these two up here under past webinars. We have another webinar coming up on how drones are being used in marine and offshore applications in partnership with Bureau Veritas. And you can see the link here. That's where you can go to find everything you need to know about the webinars we've already done and the webinars upcoming. So just wanted to mention that. I'll put that link back up actually. I also wanted to mention we had some folks with technical issues seeing Danny's videos, and we will be sending out the slides within the next 24 hours along with the recording of this webinar. So you'll be able to see the videos in the recording. You'll also be able to see the videos in the slides themselves. So we apologize. We think it's just an issue with needing to update the version of GoToWebinar that you're running. But we certainly want you to be able to see everything Danny shared today. Those videos are pretty fun, especially the ones where they try to blow the drone up. Definitely worth going back and watching. So I just wanted to mention those will be going out in an email that you'll get within the next 24 hours to your inbox. All that being said, Danny, I'm going to ask you just one more question and then we'll hop off. So the question is, oh, it just went away on me. Really, someone was asking for, let's say, a tank inspection. Do you follow the previous path that a manned inspection followed, or do you start from scratch when doing an inspection with a drone?
So if we're doing an internal tank inspection, we would want to have the historical inspection data so that we could go about the same spots and check the same spots for a historical comparison. Most likely because we're able to collect more data quicker. We would, in addition to that, get full coverage of the entire vessel. So we'd have 100% coverage of the vessel. So a little bit of both, but certainly the historical data is extremely important to monitoring changes over time. So yeah, I would say both.
Got it. That's really helpful. Okay, last question, because this is a very simple one. Someone's just asking, Rian is asking, what material you use for your tethers when you are tethering your drones?
We use like a polycarbonate material. You want something that's a little rigid. Like if you were to use like a fishing line or something like that, that wasn't very rigid, it could go and get caught in the propellers. To be honest, I would expect that Flyability probably doesn't cover having a tether on your drone. So I don't know if it's great that I was kind of promoting that today, but I would say that, you know, anything that's rigid, so you don't have the risk of it going into the cage and causing damage to the aircraft. Something that is very lightweight. Even if something's light, if it extends to a long distance, it can become very heavy. But yeah, so some sort of light plastic, certainly something that's rigid, but flexible enough so that it can, you know, move and retrieve the drone.
Got it. Thank you so much. And I mean, I'll say whether we would be in a position to recommend it, it's always useful for people to hear how our drones are actually being used, right? So if you're doing something in the field that works, whether we would want to endorse it or not, it's still something that works for you. And I think that's really important for people to know, you know, how these tools are actually being used, and tethers are part of that. So I think it's great information to share. Cool. So that's it for today. We want to thank everyone so much. We went a few minutes over. I think we could have sat here with Danny for another hour. He's just got a lot of information to share. He's a wealth of experience, as I think everyone saw today. So yeah, thank you so much everyone for attending. We're going to log off. Please look for the email coming in your inbox with a recording of the webinar and the slides. Danny, thank you so very much for joining us today.
Yeah, thank you for having me, and everybody stay safe out there. Appreciate it.
Yeah, absolutely. Okay, thanks everyone. Logging off.